举手啊，我得认人。郝爽、张昭、张旭、马思明，这字儿修振旭，好，吴瑞峰、蔡敏。这玩意我觉得是男的，他就是这看这名儿不好认，真的啊。李开宇、张倩、龙双双、陈远，陈远我认识，没来了。杨硕、孟德龙、卢国轩，干嘛去了？徐子东、王亚洲、刘金路、于洋。我说每年教材都有一个叫于洋。张欣怡。3个人。贵在汉生面吗？王涛。南静。人家你们交作业了，非常好。韦峰。许迪是面吗？是07级的猪，和05级叫猪蹄，就这字儿。张延超、沈丽、徐华天文、张琪、三七江、温亮人、志愿者熟人。好。All right, let's keep going with Tuesday's lecture. We were talking about properties. We know material science. What is material science? What is material science and engineering? This is my question. Khalid, what do you think is materials science and engineering? Between what? There are 4 things, right? What are the 4 things? Structure, yes. And what else? Properties, okay? What is number 3? Structure, properties. How do we make those structures? Processing, right? What is the last one? Performance, very good. Okay, so what is material science? Material science studies the relationship among structure, properties, processing, and performance. Okay, we've already talked about structures. When we talk about structures, what we talked about was structures has different dimensions. Like it can be as small as electronic structures. It can be as big as microscopic structures. In between, we have crystal structures, or we have microscopic structures. Okay, so structures will have different scales depending on how you want to look at them. Okay, now the second thing we need to talk about are properties. Okay, this is a place where we left off last time. Okay, so properties are the way the materials respond to the external forces or to the external environment. So these are properties. We have different types of properties. We have mechanical, we have electrical and magnetic properties. What are these? What is electrical and magnetic? Examples can be electrical conductivity or magnetic permeability. Okay? Now, we also have thermal properties. Thermal properties are related to heat. Okay? It doesn't matter if it is a conduction of heat or transmission of heat or heat capacity. Okay? So, thermal properties is always related to heat. Whenever you see the word thermal, it means heat. Okay? Let me test you with a word. What does this mean? Thermodynamics. What is this? Thermal. Must be something related to heat, right? Then, what is dynamic? Dynamic means something related to motion of an object. Okay? If you move an object, it is dynamic. So, thermodynamic studies how heat is flowing in a system. Okay? 什么叫 thermodynamic？ 是这些东西热什么？不是很导，这叫做热力学。什么热力学？你们都学过。The first law of thermodynamics, the second law of thermodynamics， 对不对？我们学过 internal energy， 对不对？我们学过 force， 是吧？好，这些东西 thermodynamics。Okay, now thermal properties are related to the transmission of heat and heat capacity. Also, we were talking about optical properties. Whenever you see the word optical, it's related to what? To light. Okay? It can be transmission or absorption or scattering of light. Okay? Optical property deals with the property related to the transmission, scattering, and absorption of lights. Okay? Now, also, this is the last thing we talk about, the stability of a material. It can be physical stability, it can be chemical stability of materials. But chemical stability of material is more and more important. Okay? Because your material is always in contact with the environment or any chemical solution. Okay? When your material is being used in service. For example, corrosion resistance is one of the examples that you can see as the chemical stability of materials. Now let's look at some real examples. For example, electrical property. What are the examples of electrical properties? Now let's look at this. Electrical resistivity of copper. What is resistivity? Resistivity is related to resistance. Okay? Resistivity is related to copper. It is related to resistance of copper, okay? Now let's look at this figure. When taking this course, you need to be able to gain a skill to read this kind of a figure. We can call this as a figure, or we can call this as a relationship chart. Okay, because this kind of a figure tells us the relationship between resistivity and temperature. Okay? Or we can say this chart tells us about the variation or the change of resistivity as a function of time. Okay, so now let's look at this. We have different lines showing different resistivity values. Okay, now the first one, what is the first one? So, black line is the resistivity change as a function of temperature for pure copper. Now what's copper? Everyone knows copper, right? This is the most common material. Okay, now my question is, why do you see an increase in resistivity as compared to pure copper for this material? Where's the difference? Because why? This is pure copper. If you add 1.12% nickel into copper, what is going to happen? You do see an increase in the resistivity value, right? Now, let's look at, this is number one. Okay, let's look at number two.